Okay, so excuse the slightly rushed-looking slides, but this talk was originally going to be given tomorrow, and I found out this morning that didn't quite work out. Little bit of history, because there's a couple of bits. This is a sort of abbreviated version of a much longer talk I've given in the past, and I've been told a couple of my biases squeak through in later slides. So just to let you know where my biases are coming from, I've kind of been doing Python a long time. It started with a 1 when I started. It rapidly became 1.5, and then we went to 1.52, which was the one true Python for many, many, many years. I don't just do Python. Like, I'm probably most well known, I guess, randomly on the internet for doing Python, but I do a lot of other languages as well, mostly because, do other languages get different ways of thinking about things. And I think it sort of comes through in a lot of what I do when I'm talking to people and teaching and giving talks is I tend to be a data structure guy rather than necessarily a, how do we do things in an imperative sense. So a lot of my sort of thinking about programming problems is I have a data structure, I have data in this form, I want to get it to this form, how do I convert the data structures? Which comes out a lot in my interest in sort of Haskell and Scheme and things like this as well. So a lot of I've been very happy in the last 5 or 6 years with Python getting more and more sort of functional tools, Itertools and things like this. I should also point out, because I noticed the front row contains a few people who are perhaps a little bit overqualified for this talk, who are all going to be very well behaved and just read their email. Probably sort of intended audience is somewhat sort of beginner to intermediate, I guess. My intention is to give you an idea of what, dip your toes in the water a little bit, provide some inspiration in about 30 minutes of something that I think is a little bit underappreciated or vastly underappreciated in the Python world, particularly generators. I mean, I say fun with iterators and generators, that's because the natural way to introduce this is to talk about iterators. But really generators are the other thing that I want to spend most of the time on. I can't afford to go too deep. I only have 30 minutes, and at some point your brain just starts leaking out your nose when you go into this in some depth. And I don't really want to do that to anybody at sort of 11 o'clock in the morning on the first day of the conference. So the idea here is to get you sort of inspired to go and look on your own. And really this is the way to learn more about this is to play with it. So, all right, let's start at the beginning. Iterators, which have kind of been around for a while, 2.1 maybe, 2.0, list comprehensions came in, stuff like that. And I mean, these are everywhere. This is every time you go for something in something else, you're basically using iterators in Python. And there's no, we're not very subtle in the Python world about naming things. It's, it is iterating over something. And there's, a standard way to set things up so that you can write, given some object, which could be something you created, it could be a list, it could be a set, it could be a dictionary. There is a natural way to iterate over these things. Pretty much every Python collection type of class comes with some sort of iterator. The iterator might have guarantees about it presents things in order. Like if you iterate over a list, you get the first element first, you get the second element second, and so on. It's not, again, we're not being subtle here. If you iterate over a dictionary, you get it in the order that the keys come out, which might not be, it will be consistent from run to run, but it's not deterministic, it's the hash order. You are guaranteed that if you iterate over the keys of a dictionary and then you subsequently iterate over the values of the dictionary, they will come out in the same order. But I think we actually made that a real guarantee a few years ago because so many people were accidentally relying on it. A set, for example, you get things that are coming out in some kind of order, but the point being that as you iterate over the set, you'll eventually get every element of the set coming out once. How do iterators work under the cover? It's basically any object that has an iter method and a next method. The next method in Python 2 is actually called next, and in Python 3 they realized next is kind of a sort of common word and perhaps we should be consistent here and put double underscores around it, and not completely unusual Python history of as these things came into language, Python sort of goes through spurts of sort of stabilization phases where everyone gets used to all the new features, and then sort of all hell breaks loose with new features going to language and language design and stuff. And whilst the people adding new features to language tend to be very, very careful and professional, they're also human beings, most of them. And mistakes get made. Things like, this seemed like a really good idea to call it iter and next. And then after a while you realize, I'd really like to use next in a lot of other places. And it's kind of annoying. I keep bumping into the iterator protocol, stealing my nice common non-underscored word. And so they In Python 3, it became _next. It's... Okay, all right, bias time. I have a little bit of a concern about the fact that you need to have both iter and next for it to be an iterator thing, because you can have iter without having next. You can have an iter method on an object that returns an iterator, but what it actually returns is something that has an iter and a next. So you start to sort of fall down the rabbit hole a fair bit. What happens in practice is if you have a natural iterator on an object, the thing returned by the iter method. I mean, this exists so that when I go for blah in some object, what Python is doing is calling the iter method to find out what is the iterator I need to use to go over this object. Almost always that is return self. And then the object has a next method that tells you how to go through things. And we'll see later on why what I just said there is not true, because we'll get to generators where you don't end up having next, but we'll one step at a time. You can have, as I said, you can have an iterator that the iter method can return, doesn't have to return self, it can return an entirely different object if you like. Not particularly common, but it's not impossible or illegal. Why do we even bother having this thing? Why not just do this some other way of not needing to have iter and next, and it's all a bit complicated and all my head hurts? You toss around the alternatives, or even go back to the discussions in, I don't want to guess the year, a number of years ago when this was coming up, and really everything comes down to the alternative is some kind of pre-generated sequence that you then just, you return a big list, or you return a big tuple or something, or you return well, we didn't have sets at that point, but you return something like a set or a dictionary. Which memory usage becomes interesting. You can imagine as your problem scales up, you're suddenly needing to store all of your results in memory at once. This doesn't work if all of your results don't fit into memory at once. It is possible to use iterators to iterate over problems like, all the moves in a chess game or something, where you just cannot possibly store all of them at once, but you can certainly go one at a time. Given I'm in a current state, I can generate the next instance fairly easily. So iterators provide us with a way to do what I'm calling here just-in-time provisioning. I can generate the next solution when I need to, or maybe I don't generate just one at a time. Maybe I generate the next 10 solutions and I walk through those, and then when I've used up that, or I generate the next 10 and so on. A web framework I work on, Django, inside its ORM, it has a very common sort of idiom of iterate over all the results of data we've pulled back from the database. What it actually does is pull back all the data, pull back a chunk of rows from the database, walks over those. When it's finished walking over those, pulls back another chunk, walks over those, and so on. So iterators can become kind of complicated under the covers, and for a user it looks very neat. You just end up going for entry in my list of results. Iterators also give us the opportunity to stop before we finish iterating over all the results. You can have infinite iterators, an iterator that generates all the prime numbers. You definitely want that to stop before it's complete. You could have something that I just want you to walk through all these solutions, walk through, for example, all the possible spelling suggestions that a tree might generate for something, or all the possible matches. Hey, I found the match I'm interested in, no need to keep going, no need to keep generating all the results, stop, you can do garbage collection and so on. So iterators have a way, if they raise stop iteration, it tells the iterator no need to do anything more. Okay. Hopefully, by the way, iterators are not surprising to people. Maybe you haven't had to write very many, but you've certainly used them almost every time you write a Python program. Every time you write a loop, you're basically hitting the iterator protocol. Python 3 has taken this to, Python is gradually moving towards everything is an iterator now that you get back from loops. Things like when you go for key in some dictionary, it doesn't make the big list of all the dictionary keys, it returns you this thing called a view that is an iterator over the keys of the dictionary one at a time. Allows you to make it happen very memory efficiently. You can have multiple iterators. I've been talking about the iter method to give you an iterator, a sort of natural iterator on an object, but there's no reason you only need to have one iterator on an object. Not everything has a single natural iterator. Graphs are kind of an obvious case where you might have a depth-first traversal for a binary tree versus an in-order traversal versus a breadth-first or something like that. So you can have many different iterator styles, and it might make sense if you want to write your code in this fashion, it might well make sense to set these up as iterators. And a tree is a very good, or a graph of some kind is a very good case where iterators sort of come out nicely, because you tend to know, well, I'm at some point in the graph, I have a sort of current state, maybe nodes I visited in the graph, and I have some kind of obvious, I can work out a next state. It might be the next state, or it might be just one of a number of choices of next state. It might be random. So graphs are a very good case where an iterator to walk over the graph is a situation you don't see very often, until you start getting involved with graph problems, and then it suddenly becomes a very natural way to write things. And again, this is probably my data structure bent of graphs come up a lot when you start thinking about things as data structures. Solutions to problems, I'll walk through graphs. Large number of problems tend to be either graph problems or approximate matching and searching when you come down to them. In the library, so this is sort of getting to the end of what we want to do on iterators. If you think, okay, I understand iterators as a for something in something type of thing, now go and read the Itertools module. Itertools is a standard module in Python, has been since 2.3, 2.2 maybe. The documentation for it is excellent in terms of the number of examples it gives you of ways to use this module, because again, it is one of these things that you sort of read it and go, I kind of understand what they're saying there, but I'm probably not going to use it. And then you put it aside and forget about it. At the moment, the documentation, about the last half of the page of documentation for the Itertools module, or 2/3 of the page, is example after example of how to do kind of neat stuff with the various Itertools things. The Itertools module contains functions like chain. For I've got 2 iterators, I want to take everything out of the first iterator, and then I want to chain that. Once I've consumed the first iterator, I want to start using the second iterator. Once I consume that, I want to start consuming things from the third iterator, and so on. And for iterator, think sequence. If you don't want to think, this is all, I have 4 strings. I want to start taking characters off the first one. When I finish that, take characters off the second one, and so on. A string has the iterator protocol on it. You can go 4 character and string. You can chain these together. You can do groupings. You can do map functions over iterators and so on. They're all in the Itertools module. It's a good way to get a feeling for what is possible here. Highly recommended, and not read enough. Okay, this isn't quite the dark side, but the darker side of iterators. You start writing them a lot, and I admit I probably overdosed on iterators when they first started coming into the language of everything I wrote was iterators. Cool for me, really kind of annoying to be my work colleagues at that point, because I was the only one really thinking like that in the organization I was in, and the code was maybe not world's greatest maintainable code. You have to write these 2 methods every time. And you get kind of sick of it after a while of, I've got to write iter and then I've got to write next. Why can't I just write next? Why is next colliding with a word I've already got used somewhere else in my thing? Why didn't they use double underscore? Particularly in Python too. So you always end up having to write an object for these things instead of just, why can't it be a function? Anyway, I mean, they're pretty minor things, but at the point it starts annoying you, it starts to assume unreasonably large proportions in your brain. Fortunately, I wasn't the only one thinking like this. And I mean, really fortunately, because I wasn't doing any work to fix it either. I was just grumbling. And we came up with generators. Generators sort of wrap up the iterator concept in a way that it can be a function. The secret sauce here being the yield keyword. This came in Python 2.2. I remember this because I had a 100,000 line odd code base that was dealing with stock markets, where I was using the word yield as a variable a lot. Not cool. It took a while to find all of the answers. And anyway, grumble. Yeah, it's always unfortunate when a language introduces a new expression or statement. Invariably, somebody's using it somewhere as a variable. In this case, it was me. So there's sort of, I have a little bit of a gripe about the way this works too. You get used to it, but as soon as you put the yield keyword into a function, it stops being a function and starts becoming a generator. What's the difference here is that when you call that function, so if I call, and I'll say function, but when I call this generator the first time, so I call gen and I pass it in a value. Again, I'm trying not to be subtle here. A value is a number. Gen of 10. It gives me back, it doesn't do anything at that point. It returns a generator object. I mean, it doesn't visibly do anything. It returns something that is a generator instance. This is something that I can then loop over. I can call, it has its own sort of next method, effectively. I can say, give me the next value, and so on. So this this particular generator says, okay, I pass in a value, providing that value is less than 10, every time I then loop around it, it returns the value and increments it. When the value's bigger than 10 or more, it just drops off the end, which is effectively equivalent to raising stop iteration, and the generator stops. So this would be a loop that if I gen of 100 would do nothing, it's almost like an empty loop. Gen of 5 would return on successive iterations 5, 6, 7, 8, 9, and then stop. But it's a little bit deceptive. Like this is okay, it's 4 lines, you can spot the yield keywords in there, it's a generator. But it comes down to naming things good. Naming things well is important when you start using generators a lot. I tend to put _gen on the end of things or _iter. Just to remind myself that this is something that it's not a function. When I call it, it's returning a generator object here. Because if this is a 50-line function, the word yield is hidden in there somewhere down on about line 37, you might miss it. Is this going to finish slide? Yes. Right, the next slide is going to use this thing, and I just wanted to make sure that no one got confused. Pretend I have a binary tree. Every node has a data object, and we have left and right trees. And there's invariably going to be something more. I wouldn't just write an object just for this little thing. But this is the sort of thing I'm talking about. It is possible, it is permissible, it is encouraged in some cases to have multiple yield statements inside generators. You don't have to have just one exit point. Basically, the yield statement means, and I'm calling it a statement here, I'll get to why actually at the moment it's an expression, but the yield statement here, every time we hit it, this function stops and returns whatever the appropriate value is. When we call next on it, when we next go around, it resumes from that point and chugs on until it hits the next yield statement. So generators with one yield statement will tend to be a big loop that it yields a value, next gets called, it goes around the loop again, yields the same value, and so on. This one is doing something a little bit different. It's saying we yield particular values inside this loop. So we stop here, we yield a value. Next time we call next, we go around again around that loop until we've done everything on the left tree. We then continues on this, falls out of the bottom of this loop. We now yield the node at the center. And then the next time around, we start going around this loop. So there's actually sort of 3 different points at which it can yield values and then resume from that point. But every time, think of yield as it's literally like the word is not, it's named obviously. It yields control back to the caller temporarily. And then when you effectively call the next iteration on it, it resumes from that point and continues. So if you have a yield statement in isolation and nothing else in the loop, it'll yield a value, and then when you resume, it'll just fall off the end of the loop again, and it'll be like almost a one value thing. You've probably forgotten to put a loop in at that point. Most generators contain loops of some kind. Here is its headed generator expressions, and I don't have a generator expression on this slide. We'll get there. Again, early days, Python 2.1, 2.0 or so on, we introduced the list comprehension, stolen from, I don't know if it picked it up from Haskell or from ML, which particular language was the inspiration here. But, we've all seen this. Iterate over some sort of sequence, call a function on it, put the results in a list. Very nice when it's about that simple. People go a bit crazy with this sometimes and have nested list comprehensions, and you can also put conditions on the end there. So for object in sequence, if object is even or something like that, call some other test, do a bit of filtering. At the point you start to see 10 or 15 line list comprehensions, someone needs to break out the for loops and just refactor their code. It's not as readable as you might think. Point here being a list comprehension returns a list, which means it has actually allocated all the memory here, it's done all the work, it's put everything in memory, which is fine if sequences a few hundred items or a few thousand items or so on. Very, very uncool if sequence is sort of gigabytes of data. And so at some later point in our life, Python introduced generator expressions. 2.6 maybe? Generator expressions, the difference here being it has parentheses around it and not square brackets. We're starting to run out of punctuation symbols in Python land, unfortunately, and parentheses are really getting overloaded these days. Because if you grow up, again, maybe my bias is, for a long time in Python, wrapping something in parentheses was basically a pointless operation unless you were calling a function. You needed to put the comma on the end to turn it into a one tuple. Other than that, wrapping something in parentheses just was a grouping operation. Now it starts to have meaning. Like, you know, this says actually do something. If I leave off the parentheses here, it's not quite the same. It doesn't actually work. What does this do? It looks almost the same as list comprehension, except it does return a generator. I mean, I'm not making this up. This is actually what the Python prompt returns. It just says generator. The point being, I can now iterate over this. I can go for something in GE, and on demand, it will pull an object out of sequence. It will call F on it. It will return the next result. So sequence here might be actually an infinite sequence or a huge collection or, you know, a terabyte data store or something. I don't have to consume the whole thing. It's quite memory efficient and so on. You don't want to go crazy. Like, remember, generators store their current state every time you stop. So you don't want to go, you know, if storing the current state is really expensive in some sense, I mean, you know, it's lots and lots of memory, there's lots of conditional stuff, you're maybe just fooling yourself into thinking you're being more efficient. I mean, under the covers, Python is not magic. It's still got to store all this information somewhere. But that's usually not a huge problem. I mean, the syntax kind of encourages you to be simple here. This leads to possibly the silliest line of code I have in production anywhere. That first method there, it actually exists in Django. And it's possibly an example of I was far too close to a problem. I needed an iterator that acted like an empty for loop, basically. And for some reason, I got obsessed on it had to be a generator. I couldn't do it any other way. It was a bit. And so the secret being, you need to use the word yield because you need to tell Python it's a generator. It can't be a function. And so I need to return something that immediately basically returns stop iteration. And I remember sort of wrestling with this for about on and off all one morning. I was actually sitting in Lawrence, Kansas, visiting the guys who wrote Django. And basically, I think Jacob Kaplan-Moss can take some of the blame for this as well. We sort of came up with this on the way to the sandwich shop at lunch and thought, you know, that just might work, and tried it out. I have a vague memory of Jacob actually SSHing into a box from like his phone just to check that, so he could run a Python command and see if it worked. We did briefly contemplate doing it this way, of immediately raise stop iteration and put a dummy yield statement in there just to tell Python this is a generator. It's sort of 50-50 which one of these is less crazy. I'm not proud of that. I probably should go in and write that a slightly different way. What I'm not showing there is about 6 lines of comments explaining what that function does. But you know, occasionally you get buried too deep. And I wrote it, what are we, 2012? Okay, so 4 or 5 years ago now, but it's still there. Next step up. Generators were useful. Generators generated functions. It was easy to write yield statements. They're functions, they're not classes. We got rid of the I need to write a class for everything. And maybe I'm a heretic here in that I don't think you need to write a class for everything. I'm not so much from the Java world. Yes?
There's a quick question with that.
Yeah.
Could you just return iter square brackets?
But then that returns something that if you iterate over it once, it gives you a single iteration, I think. I think I tried that.
Return it rather than yielding it.
Return, right, so return iter of square bracket. So the question is back here. Went back too far. Whoops, page up. Just return iter of square brackets.
Generator fixation.
Yeah, quite possibly. Like I said, I have a feeling I got too close to the problem when I wrote that. And every time I see that in the code, I keep thinking, I really should go back and write that. There's going to be about 4 different ways to... Hey, if someone wants an easy patch to an open source project, there's a one-liner there just begging to be rewritten. Oops, gone too... Right, so generators, again, not when they came out, they generated values, yielded values. At some point later on, discussion started in Python land about we wanted to have what is now the with statement. So this is there's a fairly common pattern in Python where you want to do some kind of setup information, run some function, and then do some teardown processing. And the teardown processing, you want that to happen regardless of if there was an exception earlier on, or you always want that teardown to happen. And so there's a big example here is I want to open a file, do some processing, and then close the file and not necessarily hang around waiting for Python to garbage collect the file descriptor. So I tend to go open the file, do a try block, do my processing, have a finally down the end, don't necessarily need an except, I just have a finally that closes the file descriptor. common enough pattern. Most languages end up developing something like Python's with statement after a while that says with, open file as fd, do all this stuff involving fd. The guarantee of the with statement is when I get to the end of the with block, it will garbage collect fd and tidy up the file. As part of how to implement this, how to make this nice, how to do context processes, it turned out we really needed generators weren't quite enough. Generators were close, but not quite what we needed. And there was a bunch of back and forth. There's quite a really interesting discussion on Python dev mailing list for about 8 months or so over time. Very slow motion discussion. Wasn't the only thing they were doing. But we needed a way to send values into generators. Also, generators could not, you could not yield while you're inside a try except block inside a generator function. This was sort of problematic if you wanted to be able to handle exceptions nicely and so on. So there are a few limitations like that. We ended up getting a couple of Python enhancement proposals out of this. 242 is the main one that added the ability to send information into generators. I've put generators in quotes here in the title because at this point probably the name's starting to be silly. They're not so much generating values as receiving values now. This was done by changing the yield statement into an expression. It could now return something. This is probably the point of my talk, so naturally it happens in the last 3 minutes. This is the bit that is probably the least understood area of Python in general, I would argue, as far as core language goes, is yield as something that returns a value. Let's have a look at how this works. So the idea here is our generator, and I'll keep using the word generator because otherwise it gets confusing. Yield can now return something. It still yields, it still sends something back to the caller, but it can also then accept when you resume what you can send something back into the function. Let's have a look how this works. We create the generator. Again, it has a yield keyword in here, same thing, it becomes a generate object. So we create the generator. First time round, we call next, like this is, we're doing iteration around this because it starts here, gets out of here, it yields, well, what does it yield? It yields nothing. As with most Python things where something's missing and you expect a value, it returns none. So this would return none. Generators have grown an extra method called send, where we can now send something back into it. So rather, if we called next, it would just resume from here and continue around. And if we called next at this point instead of send, value would end up being none. We sort of didn't break the natural way of working with things here. But send allows us to pass the value, when we resume this, the value 5 gets passed back into here, and value now picks up the value 5, it would print 6. And then would go around the loop again, would yield none, and then we're back to, okay, we can now go gen.send something. It is not impossible that we could make yield here return something, but that starts to it gives you headaches. Trust me on this one, right? You can yield something and pass something in, and it just gets confusing. It's not impossible, it's just not that common. So this gives us a way to send things into generators, at which point they tend to not so much be generators so much as coroutines, which are functions that cooperatively operate with other functions and yield to them, can accept values in, can yield to them when they want to. This is useful. I guess this is sort of the easiest example of something that's useful to do with them. You can construct pipelines of functions where you send something on to the next function. And so you write a whole bunch of functions, and this is my data structure manipulation bent of, I have, instead of operating on the whole data set at a time, what if I have one element of this data set? What do I want to do with it? So I'm doing something with lines from a file. I take a line in, I maybe do something with that line, I then pass it on to the next function in the queue who wants to do something with that result, and so on. Construct a whole pipeline of these suckers. Each of these generators needs to know about the next thing to call. Func here is the next thing to call down the line. Now this doesn't, what am I going to say here? Let's just think how this works. So this is being called by something else is calling this and going .send and passing in a line. So okay, we get the line, we maybe do something with it, maybe we strip off line endings, maybe we lowercase it, maybe we translate it to a different language, who knows what. I only have this much space on the slide. I didn't want to fill in the blanks too much. We then pass it on to the next function. This isn't something like multi-threading where we pass on the next function and then we continue on ourselves, right? At this point, this blocks, this in the same thread of execution hands over control to this function, which then runs, and when it yields, we come back here. And in this case, it would drop off the end, but there really should be a loop there for a real thing. But constructing pipelines of things with send is a fairly common way to build things up in a nice composable sort of way to work. It's a different way of thinking about things from maybe the way you might write this at the moment if you didn't think about yield as an expression, is you write a big for loop, for line in some input sequence, do something with line, call function on the line, and so on. But this is a different way of building things up and composing them. David Beasley, who's a very, very good Python trainer, lives in Chicago in the US, has a couple of good presentations on his website about using generators and iterators for system administration tasks, like finding lines out of really big files and things like this, and showing that it can actually be quite fast compared to things like grep. Comparable to things like grep. Doesn't blow grep out of the water because one's in Python and one's in C, but it's comparable. I've got a link to that in the last slide. Sort of his talks are well worth reading. And you'll see when you see those sort of slides, like he does a 3-hour tutorial on generators, and I'm doing a half-hour dip your toes in the water. This is why there's less detail here, so more inspiration, hopefully. As part of adding send to generators, I mean, send wasn't added because, hey, we'd like to be able to send values to generators. It was added for a very particular use case, and we want to do the with statement in Python. They also added a close method, which basically forces your generator to stop returning values. If you start trying to do something with a generator after you call the close method, Python gets very, very unhappy and throws exceptions at you. We also have the ability now that you can put yields inside try except statements in generators. We have a throw method, so you can actually tell the generator, raise this particular exception when you resume inside yourself, and maybe that can be used to control flow in some way. I don't think I've ever had to use throw beyond sort of coming up with contrived problems, but when you look in, if you read PEP 240, which is the one talking about the with statement, you can see there how it's used to implement the with statement effectively in Python. Because like most of Python, everything you can do in Python is also mirrored pretty much at the C level. Python tends to say, here's how we do it in Python, and that's pretty much mirrored at the C level in terms of data structures and so on, and that is how the C level code implements the with statement. So yeah, PEP 240 and 242 are the key things here. PEP 240 is the with statement. 242 is adding the ability to treat generators as coroutines, effectively. I can't remember the original generator statement, but that's documented in the Python documentation pretty well anyway. Those two things are worth reading, particularly 240 if you're interested in this, because it gives a lot of discussion. I mean, for those who haven't maybe read many Python enhancement proposals or ever tried to write one, a very early section in a Python enhancement proposal is the sort of rationale for why this change is coming up. Before you even get to how we're going to solve the problem, it is why is this problem worth solving? What has been attempted before? Often references to attempts that were tried and failed or tried and laughed out of court. And, there's quite a lot of history and you can see the logic going on. PEPs didn't used to get updated over time. I mean, 10 years ago when they started appearing, but 240 in particular has a big warning at the top because it's basically got two primary authors, Guido van Rossum and Nick Coughlin, and it has been edited and updated over the course of about 15 months or so, and so it sort of has this weird mixture of tense that was future tense when they wrote it and past tense by the time you get to the end of the PEP because the implementation has now happened, and it sort of spans a period from Python 2.4 to Python 3.3 or something. It looks like these guys don't speak English very well. They're actually just handicapped by the fact that this PEP has had a very long lifetime, and they don't really want to rewrite the whole thing. But it has some very good rationale for why generators should behave like this and so on. So I mean, all my gripes about the yield keyword being a bit funky, it changes the way a function is no longer a function, it becomes a generator, it can now return a value as well as accept one. It is, we're handicapped a bit in Python land by you want it to look like Python. You want it to sort of behave like Python a bit, and you don't want to break every piece of existing code out there. You want to break my code, which has the yield as variable, but you don't want to break everybody's code. And And so it kind of works once you start playing with it, but you do have to play with it. You don't think someone's going to pick up generators in 5 minutes or less. The other one, a safety tip. I mentioned this briefly before. Now that you can send things into generators / coroutines, it becomes a bit tricky if you're going to also try yielding a value at the same point that you're expecting to accept a value. It's not impossible. You can do it. You end up writing lots of notes. You end up almost invariably having bugs where you miss a step. The point being that send, when you call the send function, it resumes your iterator over here at the yield statement, loops around, gets back to the yield statement. The yield statement returns something that is returned from the send statement. So now you have over here in your caller function, send is returning something, you've got to pay attention to it. As a general safety rule, don't do that. For experts, when you start doing it, you realize, okay, I can maybe do it, it's maybe a good idea. All rules have exceptions, that's fine, but this isn't a frivolous rule, right? Been there, done that, got the t-shirt. You will have bugs. And you'll ignore this anyway, right? You will happily go ahead and do yields and sends in the same statement and get bugs and do the same as I do. Go, that guy was right. But we got to make mistakes, right? It's fine. Just be aware. I told you so. Python documentation on these things are actually pretty good if you want to go further and start playing with these. And I encourage you, go play with them. The Itertools documentation and the context-lib documentation. Context-lib is a reasonably new library, a couple of versions old in Python 2.x land that has some examples. Again, it's the with statement. Context classes are used in the with statements if you're implementing your own with things. There's some good use there of generators with the advanced send and so on. As I mentioned before, Dave Beasley's tutorials, I got a lot of respect for David's teaching in general. Any of his tutorials are worth reading, but he's done a good generator tutorial both at PyCon US and then PyCon UK. These are sort of 3 or 4 years old, but even so, it's still, everything's relevant. We haven't changed that rapidly in time. Finally, I don't know, this might be wrong, but I suspect generators are underappreciated in Python. I think there's a lot that we can do with this sort of style, sort of almost declarative-like style of programming over large data structures, functional style in Python. People don't use them very much, perhaps because they're old people like me because they weren't around the language when we started out and we're sort of resistant to change. Younger people because there's so much else the language to learn that you don't get around to using them, and the older people aren't using them, so you don't see it as part of the herd. You do need to think a bit differently. If you've only programmed in Python, generators particularly might feel a bit strange. If you programmed in other languages, like particularly functional languages, schemes, Haskells, even Erlang to some extent, or OCaml, things like that, purely functional languages, they'll feel a lot more natural. Probably a good excuse to go out and broaden your horizons a little bit. There aren't a lot of examples around. I mean, I keep pointing people to David Beasley stuff because he has done a lot of work both on his tutorials and on IBM Developer Works site showing how these can be used in not completely contrived examples. For me, I pick a lot of graph sort of traversal problems. Given a graph, find the shortest, start returning the nodes that are the shortest path through the graph, or start returning, given a big search tree, build up a tree, a TRIE tree of all the prefixes, a suffix tree type of thing, and walk through that. Generators can be quite useful for that type of thing, where you've got a very big problem space. Game searching, alpha beta searching in games, for example, you can use them for that. All right, that's as far as we're going, since he's holding up the time saying thank you. Does anyone have questions? Put your hand up so I can see them clearly. Anyone back past the first row? Oh, yes.
I'm just curious. So I'm not so happy about the iter and next thing as well. You have to define these two things. Why doesn't anybody talk about get item anymore?
I'm not sure we don't talk about it. We like get item, don't we?
But if you want to write an iterator,
yes.
then you just write a get item.
So some history here a little bit. Back before we had explicit iterator protocol, the way you would iterate over something in Python and the way sort of things like list iteration was implemented was the get item, __ get item, __. This was used in 2 different places. One is on dictionary type of things. You get item and you'd pass in a key, it would return the value. or you'd pass in a value for a list and it would return the index, like, get item 0 would return the 0th thing from a sequence. So you could write your own container classes that both took strings for key lookups and indexes for value lookups. When you went for object in container, it would call the length method on it to get the number of items in the container, and then it would start iterating through by calling get item 0, get item 1, get item 2, and so on.
The length is optional. You don't even have to do that. It'll just start at 0 and go.
And keep going, right. I think it tries to call length, and if length fails,
just keeps going until
but Python does call length and catches the exception. I found this out in Django because computing the length of a query set was really, really expensive. It required running off to the database. And I was wondering why everything went really, really slow at one point. And I was sabotaged by Python having old style and new style get items and iterators and everything. So I don't know why. I don't know why we do, except this sort of uniformizes things. The iterator get item almost feels like a bit of a hack way to iterate over something. The iterator is more explicit about, I am iterating over this as opposed to getting a particular item. So I'm not sure there's a string. Alex probably has a better answer for this, in fact.
So if you have get item, you can say foo open bracket 3 close bracket, and what does that mean, say, for a dictionary? It means something completely different than iterating for it.
Oh yeah, absolutely. I mean, it can still be a useful. I still use it for quick and dirty sometimes when I forget exactly the combination of iter and next. I've been doing this for a bit too long, and I've got get item hardwired in my brain. So anyway, it's just one of those things. It doesn't get mentioned.
We're kind of ashamed of it.
Oh,
For
sure.
But you've got the same problem I have. You've been doing Python for too long, and so these cool toys didn't exist back when we were learning that, and now we're too old to actually learn new things. So it becomes quite hard.
No. Generators are cool because they're functions with state.
Yeah, cool or dangerous.
Well, it's a nice way for you to write a state machine.
Anyway, gentleman up the back here has a question.
Artificial intelligence. Yeah.
Well, so what happens if I can try to pass some things, right?
Right now. Yes.
When a newcomer to Python language asks the specific question, what is the difference between iterator and iterator? How do you unambiguously explain it?
I try to avoid being in a position where someone asks me that question. I mean, generators, see, an iterator, I mean, it is a little bit of a, it's maybe it's not sort of a newcomer might well ask the question. It's maybe the wrong question to be asking as a newcomer, but it's that never, no one's ever been saved from asking adventurous questions at too early a stage. It's how we learn. Iterators are the iterator protocol is kind of what defines the iterator. They have a next thing for generating the next item. Generators happen to be a particular way of implementing that by having this thing that yields values, right? They're a particular type of object inside Python. But there are many other ways to implement iterators. I was doing effectively iterators back in Python 1.5 because I stole stuff out of scheme implementations where you'd have this thing called promises, a class that basically encapsulated the state and would have a method on it called force or deliver or something that would return the next value and itself and its updated state of itself. And so you could happily sort of generate infinite streams of things by having these promises that force would return the next value. So it's not particularly difficult. You could invent iterators, right? You often do out of necessity. It just happened Python encapsulated. Generators are a specific way to do iterators as functions. They came along later historically for that kind of reason. We didn't rush into it. We needed iterators, and later on we went, okay. I think even way back in the iterator days, right? I mean, when that was being discussed, people were saying, so there should be a way to do this with functions. Yeah, let's get it right first, and then we'll come into that. And that sort of went, that was pre-crazy feature development days.
Okay, I think we should call the session because it's lunch. Thank you very much, Malcolm, for your talk.